Good morning to the session chairs and a big thankful to the organizing committee of ICCKE 2022 conference for accepting our paper to present in this esteemed conference. Coming to this title of this my research work, this is load frequency control of geothermal power plant incorporated to area hydrothermal system with AC/DC lines. And myself is Ch.Naga Kalyan. I'm an associate professor from Vasireddy Venkatadri Institute of Technology, Guntur, India. Coming to the main highlights of my work, LFC of means load frequency control of two area hydrothermal system with geothermal power plant integration has been presented in this work as a test system model, and PIDD controller, proportional integral double derivative controller, which have been tuned with water cycle algorithmic technique, is implemented as a secondary regulator. Further, the efficacy of the presented PIDD controller is validated with other classical controllers of PI and PID, and the supremacy of the water cycle algorithmic technique is established with the other available approaches that are available in the literature. Thereafter, AC/DC lines, an additional HVDC line has been laid in parallel with the existing AC line, which becomes acts as a AC/DC lines of a territorial control strategy has been adopted, and the system performance is enhancement and the system performance is noticed. These are the main highlights of my present work. So this is the power system which have been considered for the investigation, which consisting of two areas, two control areas. This is control area 1 and this is control area 2, and each control area comprises of traditional power generating sources of thermal and the hydro units. Uh, Moreover, a geothermal power plant is a geothermal power plant, a transfer function model of a geothermal power plant, which have been incorporated in the area 1. So, in order to conduct the research work more close to the realistic practice, realistic constraint of generation rate constraint have been considered for both the thermal and the hydropower plants. This is the model of a GRC, which have been considered for the thermal, and this is the model of GRC considered for the hydropower plant. And this is of a HVDC line, which have been laid in parallel with the AC, which we enacted as a territorial control strategy. And this is of a slot for a secondary regulator. Here in this work, PIDD controller has been taken as a secondary regulator. So the entire analysis on this test system has been carried out by laying a 10% step load perturbation on area 1. Here this is of an area 1, this is of an area 2. Here a 10% step load perturbation has been laid here. Coming to this controller and objective function, in this work, PIDD controller has been taken as a secondary regulator because of numerous advantages. So till now, 90% of the industrial sector is utilizing the classical PID as a main controller. So because of design simplicity and operational efficacy, so uh, to enhance the performance of a classical PID controller, this PIDD controller has been emerged. Nothing but classical PID plus additional double derivative gain, which becomes a PIDD controller, whose design structure is similar to that of PID and exhibits a better performance than a classical PID controller. So the gains of this PIDD controller has been obtained optimally using the water cycle algorithm, subjected to this minimization of integral square error objective function. This is an integral square error function which have been framed in this work, which comprises of delta f1 means frequency deviations in area 1, delta f2 frequency deviations in area 2, and delta p tie 1 to Taylor power flow deviations. Okay, so we have four time domain based objective functions, of which most of the researchers have been utilized the integral time absolute error ITAE, but in this work we have considered the ISE. From our experience, what we came to know that ISE exhibits a balance between bringing the responses to the steady state position in quick time as well as diminishing the peak magnitudes, whereas the ITAE is only focused on bringing the responses to the steady state condition in a quick time. So whereas this ISE is focused on balancing these two situations of diminishing the peak magnitudes as well as bringing the response to the steady state in quick time. So that is why we are motivated to adopt this ISA objective function in this work. Coming to this water cycle algorithm, this water cycle algorithm is also one of the newest optimization technique which emerged from the water cycle in an atmosphere. So normally when rain falls, it always starts with the water drops. Thereby it will forms rivers, streams, and finally these streams and rivers will merge into the sea. So in this water cycle algorithm, these raindrops act as the initial population and sea is a global base solution. So, water cycle algorithm is far better than many optimization techniques that are already available in the literature. And moreover, implementation of this water cycle algorithm to the power system stability and power system operation and control is not rigorously reported in literature. So, this is one of the reason we have adopted in this work. And the detailed mathematical model has been mentioned in the paper. And here is a flow chart. So coming to this simulation results, we analyzed the two-area hydrothermal system with GTPP incorporation in three cases, and this is of a case one. Analysis of GTPP integrated two-area thermal hydro system with water cycle algorithm based controllers. So these the dynamical results or dynamical responses have been compared for a step load participation of 10% on only area 1. So we have implemented three controllers. One is proportional integral PI, proportional integral derivative PID, and proportional integral double derivative, that is PIDD, one after the other. And these are the simulation results. If you see for the same disturbance conditions, definitely the dynamic behavior of the two area hydrothermal system with geothermal power plant integration under PIDD controller have been less deviated compared to that of PI in pink color and of PID in a blue color. And moreover, the dynamic responses under PIDD reaches the steady state position in quick time compared to that of PI and PIDD. If you see, both the peak undershoot and the peak overshoots are very less with our proposed control, that is water cycle algorithm based proportional integral double derivative controller. Okay, if you see the responses in deviation in area 1 frequency, deviation in Thailand power flow, and deviations in area 2 frequency, everywhere the proposed controller PIDD outperforms the other integral order controllers of PI and PID in terms of both peak undershoots, peak overshoots, as well as the settling time. So this shows the predominance of the PIDD or the classical PI and the classical PID controllers. This is of a case one. So from this case, PIDD is revealed as a the best controller. Coming to that of a case 2, analysis of GTPP integrated to area hydrothermal system with PIDD regulator using various algorithms. So these are the system dynamic behavior for a step load perturbation of 10% on area 1. And here PIDD is enacted as a secondary regulator in both the areas of two area hydrothermal system with GTPP integration. Moreover, the PIDD controller has been optimized with various optimization algorithms like WCA, water cycle algorithm, HAEFA, hybrid artificial electric field algorithm, and Gray Wolf optimization algorithm, one after the other. And all these algorithms has been utilized with 50 populations for 50 iterations. And these are the comparative analysis. The proposed algorithm results have been given in red color, and the already existing methods under the existing method, the dynamical responses have been given in black and a blue color. If you see, definitely the responses in the red color are very much controlled with less peak undershoots, peak overshoots, and as well as the oscillations are also very less, and they reaches the steady state in quick time compared to the other algorithms which are recently proposed by the authors in the literature. So, moreover, this water cycle algorithm based PIDD effectively damps out the oscillations in the system dynamic behavior compared to that of HIEF and GWO. So, WCA is more efficacious than hybrid artificial electric field algorithm and the gray wolf optimization algorithm techniques. So, and these are the responses settling time, numerical analysis. Here are the settling time of the responses. Suppose for PI optimized with WCA algorithm, these are the responses settling time. For PID, PIDD, and PIDD based on gray wolf optimization, and PIDD based on hybrid artificial electric field algorithm. If you see, definitely the PIDD controller with water cycle algorithm is the responses reaches the steady state condition in quick time. That is, settling time is very low, which means the responses reaches the stable position in quick time compared to that of other controllers and other algorithmic techniques. Moreover, the minimization of the objective function is very effectively done with the proposed control technique. The objective function is 126.34 in 10 minus 3 for PI, 87.19 for PID, and for PIDD that is 34.76. That means the objective function is very much minimized with the proposed control technique. So from this point of view, we can also conclude that the PIDD is more effective in optimizing the uh, getting the controller gains by making use of the water cycle algorithm technique. So coming to this table 2, these are the controller optimal gains which have been found using different algorithms. These are the gains of PI, PID and PIDD from WCA, gains of PIDD from GWO, this is of a GWO, and this is of a HAEFA, gray wolf optimization and the hybrid artificial electric field algorithm. These are the optimal gains that have been found using the different optimization algorithms which have been used in this for the system dynamic behavior. Coming to this case 3, analysis of GTPP integrated two-area hydrothermal system with AC-DC lines. Here, additional control strategy, that is territorial control strategy is implemented to further enhance the performance of a two-area interconnected power system. So for this, an additional HVDC line, high voltage DC line has been laid in parallel with the existing AC tie line, together called as an AC-DC lines because we are connecting two lines which facilitates the bulk power transmission between the two control regions. So normally the major advantage of implementing this interconnected power system is to facilitate the power exchange between excess and the deficit control regions in order to make the interconnected power system, every control region in an interconnected power system in a stable position. So if you see the dynamical responses for a step load perturbation with only AC line and within AC and DC line, these are the dynamical responses. Definitely, by implementing the AC DC lines, definitely the peak undershoots and the peak overshoots have been very much diminished for the frequency deviations in area 1, tail and power flow deviations, as well as frequency deviations in area 2. So definitely a considerable enhancement in the system performance is noticed by implementing the ACDC lines. So these analyses have been done under the secondary control of PIDD based on WCA technique, because the WCA based PIDD is already exhibited as a already declared as a best controller, and the further analysis have been continued with the same controller only, right? So this paper recommends the usage of ACDC lines as an effective territorial control strategy in order to obtain a considerable enhancement in the system dynamic behavior. Coming to these conclusions, WCA based PIDD is more effective, especially for the load frequency control of multi-area interconnected power systems, And the efficacy of the proposed control technique has been demonstrated with other classical controls of PI and PID, as well as the soft computing techniques of GW and HAEFA, which are already available in recent literature. Further, the performance of GTPP integrated to area hydrothermal system is enhanced with the implementation of AC/DC lines. So these are the major outcomes of this proposed work. These are the references which have been worked on to furnish. Thank you so much. Once again, I would like to thank the organizing committee of ICCKE 2022 for accepting our paper to present in this esteemed conference. Thank you.